Okay, I'd like to thank everybody for coming out today. This is our third visit out to talk about the Columbia Turnpike Bridge over the Black Brook. This is a local concept development study. We were previously out the first time for our first round of meetings back in May. May 9th is when we had our first public information center. Then we came back out in September 11th for our second, and we're here today to present our findings as well as the preliminary preferred alternative. The second slide again shows our project team with our project sponsor being Morris County. We also have other participants including the DOT, NJTPA, who's the grant administrator, and the U.S. Federal Highway Administration. And these agencies provide technical and financial support as well as compliance with state and federal regulations. And the bottom row there is the consultant team that is conducting the study. So the purpose of the meeting today is to provide a brief summary of the local capital project delivery process. And you can see some of the boards that are lined up on the opposite side of the room here to me, which illustrate the process. And I'll get into that in a little more detail in a couple of slides. But not only the local capital project delivery, but also the local concept development process, which is what we're in now. We're also going to provide the status of the study efforts to date. We'll present the project purpose and need, goals and objectives, and that was something that we developed with the help of all of you providing us valuable input into the project issues. We'll also talk briefly about the improvement concepts that were developed. This is what we covered at the last meeting, so we'll run through them briefly today so you can see what we've looked at along the way to get to the preliminary preferred alternative. And then lastly, we will present that preliminary preferred alternative in greater detail. Okay, so in terms of the project overview and background, the bridge is located in Florham Park Borough, Morris County. And again, it's illustrated on a few boards here, the project location. It was built in 1929, so it's pretty old, 89 years now. The bridge its current condition is in need of rehabilitation or replacement. So in November of 2017, the NJTPA in Morris County initiated the local concept development study. And with McCormick Taylor on board to conduct the process. The local capital project delivery program provides the opportunity to advance the project with public input. That's why we've come out to you for now the third time, so we can get input along the way as we're going through these various phases of the process. And this input's been very valuable in not only developing the purpose and need, helping us develop the alternatives, but also with the selection of the preferred alternative. So we appreciate all of that. In addition to the input that we've had from you, the public, we've also had stakeholder input as well as agency collaboration along the way. So here's the location map. Again, there's some boards around you to see where the project is at. You can see it's just to the west of the interchange with Route 24. You can see the Morristown Municipal Airport there in the northwest corner. Here is an aerial map which is zoomed in a little bit closer, and you can see some of the facilities or some of the features in the area. There's the Cadillac dealer, the open road Cadillac dealer to the northwest. We have the Matt Cali Business Park down there to the southwest, or southeast. Eli's is right there to the northwest. And of course the bridge carries to Black Brook. So this is the local capital project delivery process. There's 4 phases here: the concept development phase, preliminary engineering phase, final design, right-of-way acquisition phase, and construction. We are in that first phase there that says local concept development. The first 2 times we've been out to talk to you were to initiate the public outreach efforts, which you can see is the second bullet there, and then we came back out to discuss the alternatives that we were developing, which is the 4th bullet under the local concept development bar there. And now we're back out describing the preliminary preferred alternative. And this We're in this phase now, which is about an 18-month process. By the time we get to construction, these next two phases will probably be about 5 years. And then construction will probably be about 22 months, as Peter will talk about when he's into the PPA. Now, when we take a closer look at the local concept development process, and again, this is what we're in now. This is that first bar in the project delivery process. You can see that community outreach is a component of each of these phases or tasks along the way. So the first time we were out, we were talking about the existing conditions, we were developing the purpose and need, we were soliciting input from you, the locals here, as to what some of the other problems may be that we're unaware of. And we've done that, and we appreciate your input. Then we came out and we talked about the alternatives. We had developed several alternatives that we presented. We obtained input from the group. We took that input back, and then we refined it. And through additional coordination with the locals, the stakeholders, and the local officials, we've developed a preliminary preferred alternative, which we're here to talk about today. So more about the bridge itself. Again, it was built in 1929. It was widened to the south in 1960. The bridge type is a single-span bridge. It has concrete, steel, encased steel beams and rolled steel multi-stringers. Its length is 35 feet. The width is 45 foot 7 inches. The posted speed limit along Columbia Turnpike here is 50 miles an hour. It currently contains 2 lanes in each direction with no outside shoulders at the bridge. And there are sidewalks on the bridge which are 4 foot 11 inches in each direction. And the ADT is quite high here. This ADT was taken in 2018, and it's 33,840 vehicles per day. So lots of traffic there. The condition of the bridge, it's in overall it's in fair condition due to the condition of the superstructure. And the superstructure is everything from the beams and up. And that's in fair condition with a rating of 5 out of 10. And that's due to some section loss, which we'll show you some photos of. There's rusting at the beam ends, there's heavy rust, there's staining, spalls, laminations, the diaphragms with section losses and holes. And again, we have some pictures that we'll show you. There's also some photos on the opposite side of the room there. The bridge is considered to be functionally obsolete based on the substandard width, and that's specifically related to the shoulders, or lack thereof. And the sufficiency rating is a 57.5 out of 100 based on the 17th cycle. And that's a bridge reevaluation report, which is conducted every 2 years. So some of those photos that I was talking about. So this one here shows the underdeck on the original section. This was the piece that was built in 1929. And you can see efflorescence. This is that white stuff there. And that's where when the water infiltrates there and it dries out and evaporates and leaves that alkali type material there. This is the newer section, built in 1960. You can see this is an I-beam here. Again, you can see the corrosion down here. You can see the rust happening at the abutment there. Again, you see some rusting, some cracks in the abutment area here, efflorescence. So you can see that's in poor condition there. And here in this photo here, you can see some spalling happening at the east abutment. So in addition to those issues on the bridge itself, there's also some environmental and site constraints that we need to take into consideration when we're looking at this bridge. We do have some features that are right in close proximity of the bridge, including Eli's, which I don't have my pointer, but I think everybody in the room knows where Eli's is. It's right in this location here. All of this green in the area here represents wetland areas, so that's a sensitive area that we try to avoid, minimize if not avoid at all lengths. There is a property right here which is listed on the National Register of Historic Places. The structure's been removed, but the property itself, the land itself, is still considered historic. There's a pump station just opposite the Cadillac dealership, and then you have the Cadillac dealership itself, as well as an office building. So We do have quite a few things out here. I know the area seems rural, but right in the immediate vicinity of the bridge, there are some features that we need to consider when developing alternatives. We want to make sure we avoid, minimize impacts to all those things. And here are some of those features that I just described. Here's the sewer pump station. This is on the southwest side of the bridge. This is Eli's Aquatic Fish Farm. This is located right next to the bridge on the northwest side. This is the office complex, Matt Cali. This is on the northeast side of the bridge. And then the municipal, Morristown Municipal Airport, which is located on the northwest side. So in terms of the status of the project, in November 2017 is when we started the LCD study. In the spring, we had completed the data collection. In the spring, we also held our first local officials briefing, as well as the Public Information Center. Then in June, we developed the project purpose and need statement. In the summer, we developed the conceptual alternatives. In August, we came back out to you for the local officials briefing number 2. And in September, we had our stakeholders meeting in Public Information Center number 2. And here we are on the 12th of December to talk about the preliminary preferred alternative through the local officials briefing and the Public Information Center. So the purpose and need for this project is stated here. And again, this came from input from the various stakeholders and locals that we had spoken to through these meetings, as well as our own research from reports and field and site evaluations and things of that matter. The bridge is currently functionally obsolete due to the substandard roadway shoulder widths, and it's in overall fair condition due to the condition of rating of the superstructure. The superstructure condition is fair with a rating of 5 out of 10, and the substructure is satisfactory condition. The bridge currently has a sufficiency rating of 57.5. So that's the need. Now, we also have some goals and objectives that we would like these alternatives, and specifically the PPA, preliminary preferred alternative, to meet as many of these as possible. And we have addressed bridge structural deficiencies. We'd like to upgrade the bridge and approach roadway conditions to meet AASHTO and NJDOT safety standards, including new parapets and guide rail. We'd like to minimize the environmental, social, and economic impacts in the project area. We want to minimize the impacts to the Black Brook. We want to minimize impacts to the existing utilities, including water, gas, electric, telephone, and fiber optic lines, all of which we have in the area there. We want to minimize disruptions to traffic operations during construction. We want to maintain the access to the adjacent businesses at all times during construction. We want to minimize the use of detours. If detours are required, utilize the state and county roadway networks to the greatest extent feasible. And we also want to provide bicycle and pedestrian compatibility to the approach roadways. So those are the goals and objectives. Like I said, we try to meet as many of these as we can. Often we cannot, but it's certainly our goal, and the ones that pan out to be the PPA usually successfully achieve in meeting most of these. So again, this is the existing bridge site, it's zoomed in a little bit more. Here's Eli's, just to get your bearings here. So some of the critical design parameters that we were looking at for the alternatives are given here. The structure life, the life cycle. Certainly we want a strong, durable, cost-effective, and a bridge that has minimal maintenance, cost and in terms of duration. We don't want to be out there all the time. We don't want it to cost a lot to maintain this bridge. In terms of hydrology and hydraulics, we can't have floodwater increases of greater than 0.04, which is a ½ an inch. That's upstream or downstream. We can't increase that floodwater elevation. So that is all impacted by how wide you make the bridge opening or narrow. So that's something that we have to really keep a close eye on as we're looking at our alternatives. Or, as you'll see, we have a skew on our PPA because we had to tie into the brook, and it's just the right angle there. Staging, we want to maintain the current traffic capacity on the Columbia Turnpike, and we have to do that by keeping all 4 lanes open. I mentioned that the ADT was 39,000 vehicles per day, and when we took some and looked at that through traffic modeling, by reducing that to 3 lanes or 2 lanes, we had tremendous spillbacks. which, those of you that are familiar with the area know that when there is some flooding that occurs up towards the Route 24 area, going to one lane in each direction really causes some jams and extensive queuing. So we need to avoid that. Roadway geometry, we need to address the substandard geometries. We already talked about substandard shoulders. If we have substandard cross section or cross slopes, we'll correct those on the bridge to promote better drainage. We mentioned there the wider bridge to include outside shoulders. And then in terms of environmental and utility impacts, we have wetland impacts to the south side and the northeast side that we need to avoid. There's wetlands around the whole area, and we really need to try to avoid those to the best of our ability. There's a lot of utilities in the area. So the two that we really need to avoid are the 26-inch gas distribution line and the 36-inch water main. They're both on the north side, and we've been told by the utility providers that these cannot be disconnected or relocated even temporarily. So with that, I'd like to turn it over to Peter, who's going to talk about the alternatives as well as the PPA.
Thank you. Again, my name is Peter Berg with Trans Systems, and thanks for coming out tonight. I appreciate that. The alternatives that we had developed, obviously there's 7 of them. There's a no-build option, a bridge rehabilitation, and a replace in kind. Obviously, none of those 3 met the purpose and needs of the project. So we developed alternatives. 1A to 1D, which is a new bridge on the existing alignment of the road. Alternatives 2A and through 2D, which is a new bridge on alignment shifted to the south. And then alternates 3A to 3D, which is a new bridge on alignment shifts to the north. And then finally, alternatives 4B through 4D, which is a new bridge with a minor shift to the south. So the superstructure types that we had looked at were pre-stressed next beams, which are precast concrete, steel beams, and then pre-stressed concrete spread box beams, which are concrete, and then pre-stressed concrete adjacent box beams. So within those alternatives, there was design factors and implications that there were correlations of things that would cause it to another impact. So with stage construction, the more stages you have, that obviously equals a longer project duration, and there's additional constructability challenges. With less stages, there's more durability, less cost, and less maintenance. With the roadway alignment shifts that we were proposing, the greater the alignment shift in either direction equals less stages, but the project limits would get longer on the roadway, which you can see in some of the roadway plans here. Also, that would equal less environmental, utility, and property impacts. I'm sorry, with the less alignment shift, there would be more stages, shorter project limits, and less environmental, utility, and property impacts. With greater alignment, there would be more environmental impacts, utility, and property impacts. With the greater alignment shift to the south, there was an even greater impact into the wetlands, which would require additional retaining walls that would have the impacts into the wetlands. With hydraulics, the greater the span opening means there would be increased flood water surface elevations downstream. Again, we're talking about 1/2 inch, we can't exceed that. With matching the existing span opening, there's basically no increased water surface elevations downstream. With the superstructure types, we have a thicker deck and adjacent beams that would basically create a structure that is less susceptible to concrete deck cracking, which is critical. With the spread beam superstructure types, there was more constructability with it with the staging. with the wider accelerated bridge construction superstructure types like the next beam or the inverset, there was less constructability with staging. So we went through all the alternatives and came up with this matrix here and all the factors, and it basically came to alternative 4D. And you can see the matrix over here if you want to get a closer look at that, all the factors involved in that. So for 4D as the PPA selection summary, what this alternative best addressed everything, and it maintains 4 lanes during the construction, avoids a detour. It removes the substandard design elements. It provides a 75-year structural life cycle that is cost effective, and it provides lower maintenance over the life of the bridge. Has a minor alignment shift to the south, creates a comparatively shorter project limits on the roadway, minimizes impacts to the wetlands, avoids the significant utility impacts to the gas main and the water main to the north, and it minimizes the property impacts. The superstructure beam types are the adjacent box beams, and it has a thicker deck, providing less susceptibility to the concrete deck cracking, and that'll strongly contribute to long-term durability. There is an additional cost for that structural upgrade, but comparatively in the overall project, it's less than 2.5% of the overall project cost. So this alternative best addresses the hydraulic challenges and avoids the stream impacts and also the relocations. We provided a 12.5-degree skew at the inlet for the whole bridge to avoid any relocation of the channel at the inlet. It provides sidewalks and bicycle compatibility, and it's built in 5 stages with a construction duration of approximately 22 months, basically 2 construction seasons. Preliminary cost is estimated at $3.85 million. So here is the plan view of the bridge. You can see the skew in it in there. It's a approximately 32-foot span, face to face of the abutments. You can see it in elevation down here. This is the PPA roadway plan showing the alignment. You can see the slight shift to the south, still maintaining within the existing right-of-way though, and avoiding the utilities to the north there. This is the PPA roadway profile. We're raising up the profile on the eastern side slightly, just to smooth it out there and take away that substandard element. We can kind of go through the staging. Basically what the staging is, it provides a way to maintain the 4 lanes at all times. You can see as we progress across, we run into the utilities in the center there, and we have to provide a utility bay for them to continue on with their utility connection there. And from there we continue across until we get to the final condition where we have the 4 12-foot lanes, the sidewalk, and the 2 8-foot shoulders.
Thanks. And through a couple of those slides, one picture had shown was a summary of the PPA, and a lot of those items that were bulleted there were in fact checkoffs on the goals and objectives that we were talking about through earlier. So we can see that we were meeting the majority of those goals and objectives. And this slide here, we were showing, this is really a critical utility. This is the 26-inch gas main, and this isn't shown vertically to scale, but it is horizontally. So this is what we were working with on that north side. We needed to stay away from that at a distance that is constructible for the contractor to get in there and provide the sheeting. So this was really our constraint on the north side. As we mentioned before, this is something that we were told by the utility provider that couldn't be relocated or temporarily shut down or bypassed, so that was a major, major constraint. So in terms of the project schedule, as I mentioned, we are in the local concept development. The entire schedule length is 18 months, which will take us to June of 2019. That's when we'll be wrapping up this phase, and then the project will enter the preliminary engineering phase. But some of the major milestones, the purpose and needs statement we completed in June of 2018. We developed the conceptual alternatives in August. We selected the PPA in this month, in December. We're going to submit the draft LCD report in March of 2019, and then we plan to complete this phase in June of 2019. The community involvement schedule is listed here, and as I mentioned before, we were out two times before this, and they're listed here, the dates. When we were talking about the project introduction and the purpose and need, we came out to the local officials briefing on April 24th, and then we had the Public Information Center on May 9th. When we were looking to get input on the conceptual alternatives, we were out here with the local officials on August 30th, and then we were talking with the stakeholders on September 11th, and then we came out for the Public Information Center the same day. It was actually the same room on September 11th. Those two meetings went back to back as they are tonight. So here we are now with the selection and presentation of the PPA. We had the local officials briefing earlier today, and we're now holding the Public Information Center. And following this is actually the last round of meetings that will be coming out during this phase, but there will be more public outreach during the next phases from preliminary engineering and into final design. So this outreach continues throughout the whole process. And in addition to any questions that you might have for the team tonight, we do have a project website that's been up and running since back when we initiated the project, and the website is listed here, www.columbiaturnpikebridge.com. On there you'll see all of the previous presentations, you'll see a lot of our work products, you'll see a lot of the data collection items, so we encourage you to visit those websites to get any other additional information that if we haven't answered for you tonight, please visit that. We also have a Twitter account with the handle indicated there, twitter.com//Columbia Bridge. So we encourage you to look at that too for upcoming events and posts. And this PowerPoint presentation, like the others, will be uploaded to the project website following this presentation. In addition to that, additional contact information, we have Megan Pachione, who's sitting in the back here. She is the Morris County Senior Engineer and the lead on this project, as well as Rich Brundage from the NJTPA, and he's the TPA's project manager. And this is their contact information. Okay, thank you.